Let's ask ourselves why data modeling is critical for a reporting solution. Well, think of challenges like user experience, data quality, maintainability of your solution, and most importantly, performance of your overall data platform. There is one solution which can actually help you in every single one of these, and that is a good data model. So how do you make it happen? Well, firstly, you need to design a good data model. Secondly, you implement that baseline data model with all the right interfaces and all the right infrastructure. Then you add some calculated attributes which will help you in the long run. And then lastly, optimize the performance where you feel you need some more action. All right, so let's make a start with OD2, which is modeling the data. In this particular OD, we are going to talk about four things. How do you go and design data model? Developing a data model, and then creating measures using something called DAX, which we will talk about, and then optimizing model performance. So let's make a start with the first one, which is designing a data model. When you think of modeling, the first thing that comes to us is data relationships. When you source your data from your data sources, there is a very good chance that the data source itself has relationships, and when you get that in Power BI, those relationships will be identified and retained, and that you can review as well. Now, when you have this kind of a scenario, or if you go and build your own relationships as well, just be careful with few of the things. So for example, when you look at modeling the data, you need to think about whether or not diagrammatically it's looking okay to you, right? When you have done this, you have to think about what kind of efficiency and quality will come out from data aggregations. And when you're looking at establishing relationship between tables, you also have to think about things like whether it's going to be unidirectional or multidirectional or bidirectional rather, and what kind of, what's the nature of the relationship itself? Is it one-to-one, one-to-many, many-to-many, and those kind of things. So all these bits and pieces, they do go a long way when you look at each of the relationships. And again, in some cases, the overall architecture of data might be quite huge. Take your time and go through the relationships, because if they are correct, it will help you a lot later on. Another thing that you need to be conscious about is data granularity. A good example for something like this is this. There could be one table which is giving you data on a daily basis, and there is another table which is probably giving you data on a weekly or a monthly basis. When you have these two tables and you want to join them together, as you can imagine, joining them is not going to work, at least on the onset. So something you need to think about. There are times when you need to go back to the source to get something like this corrected. In some cases, you need to address that within the modeling solution on your side. Irrespective of where that is, just be conscious of data granularity and know that that's a concept that's available, and you can do something about it in Power BI at the modeling step as well. One thing I do want to call out, again from reporting perspective and data solutions perspective, that data granularity is an absolute and foundational consideration, and not having it correct will have repercussions later on which you need to be aware of. If you think about a few more things which are worth knowing and exploring, relationships we already talked about. Another bit which is important is cardinality. Cardinality is more about what is the nature of relationship looking like. Is it one-to-one? Is it many-to-one? Is it one-to-many? Or is it many-to-many? All these different things mean differently when it comes to aggregations, when it comes to data filtering and those kind of things. User experience would vary with each one of these. So be sure that the cardinality is right among the relationships that you see in the data. And if they're not, then try to rectify that. Again, it could be something that you need to get resolved as a bug in the source system, or it might be something that you might want to address within your control as well. One critical aspect that is worth noting is Power BI does provide you not just the cardinality and few of the bits and pieces we talked about, but we also look at the direction of relationship. And what that means is that they could be single directions or they could be bidirectional, as in both tables which participate in a relationship, they can filter each other. Or there could be one table which is more driving and filtering rather than the other. So that is quite critical as well, and something again that I suggest you explore a bit more before you go and sit the exam. There is some good documentation available out there on Microsoft Docs site. In this particular case, we're talking about how do you enable bidirectional cross-filtering. And as you can imagine, as you can see in the screenshots, it actually does give you very specific pointers on what is happening and where. Now, once we have done all of these things, there are times when data model as sourced from the data sources is not great, and yet it won't be fixed just because you are saying so. So there could be scenarios where you might need to do few more bits and pieces. Some of this could be that you go and create calculated columns, for example. And those are like additional attributes that you store with the data. They're not in the source data set, but you create that for your reporting purposes. But when you do that as well, just be conscious of the fact that whether the relationships are going to help that in that or not. For example, in this particular case, if you think about it, if there is a change in dimension customer table, that will lead to some data which would require to be changed, for example, in fact sales table, which is F sales here. And likewise, in some very specific edge scenarios, it might demand a bit of a change in dimension salesperson table as well. So just be cognizant of those things. Think about when you're adding some of these calculated columns, how these changes can flow through and how they can influence and impact the outcomes. Now, again, one more documentation page that we probably should be visiting, and one of that is how do you go and work with the modeling view in Power BI Desktop. And with that, what I also want to call out is there are at least 3 different views that you can work with in Power BI. You should be aware of them and you should also be leveraging them. So let's go forward and let's now talk about the second particular subset, which is around developing the data model. Before we actually get started with it, let's introduce DAX. I think you are already aware of it, most of you at least, but if not, this is one of the programming languages which can be used to create calculated columns, measures, and calculate tables, and a lot of different things like functions, operators, parameters, this, that. It actually can do a lot of hard work and calculations and can give a rather simplified outcome for the consumers and users to work with. It's very, very powerful, and it can be using things like variables and those kind of things, which can really make it very dynamic. And can be used in a lot of different ways. Can be used in time intelligence. It can be used in advanced analytics and those kind of things. And as I said, it's a full-blown programming language which actually can do a lot of complex work for you. Whenever you go and create some calculation, for example, a calculated column in this case, that is actually using a DAX formula. So in this particular case, what it's doing is that it's looking at creating a calculated column called total price, and it's going to multiply quantity column with unit price column. As you see, there is a reference to the table name, which is sales order details, and then there is specific reference to quantity and unit price columns, and that's how a calculated column is being created. Now, this is obviously very, very simplified version, which you can explore a bit more, and at the same time, there is more complex versions that you can play around with. There is full-blown tutorials around how do you create calculated columns, things to be aware of, caveats to be watching out for, and all those kind of things. So please do explore that a bit more and leverage the power that this brings to you. Now, you don't have to go and write everything by hand. End of day, this is a self-service tool that we talk about, right? The similar thing that we can do in a DAX formula, to some extent, in fact, to a great extent, we can achieve that using quick measures. Behind the screen, when you go and trigger and go about creating a new quick measure, it actually is creating the DAX formula and DAX code by itself. It's just that you are doing all of that in a visual and GUI way. When you go and create your measures, you could be summarizing data, you could be calculating things like measures and averages and divisions and multiplications and a few other complicated calculations as well, which can go towards the statistical analysis side of things as well. All of that is possible using quick measures, and it actually takes care of generating the DAX code behind the screen, and you can go forward from there. Again, documentations are available. You don't have to go and remember each one of those mechanisms or all of those quick measures and types and everything that you can create. But just know that you can do things like time series analysis, calculations, statistical analysis, and those bits and pieces using this. So we did through a couple of terms there. We talked about measures and we talked about calculated columns. So what is the difference between these two? I mean, when should I know that I'm using measures, and when should I know that I'm using calculated columns? Measures are calculated based on the filters. They are not persisted. When I say persisted, they are not stored with the data itself. Whereas calculated columns, they get calculated for each and every row, and they get stored with the data. So what that actually means is that calculated columns will lead to increased data size in your Power BI reports, whereas measures gets calculated in the runtime every single time. So you have to be conscious of the fact that if there is a calculation which has to happen a lot of times, almost every time, and every user is interested in that, maybe you are better off storing that as a calculated column, because then you don't have to redo the calculation all the time. But at the same time, if it's an ad hoc thing and if it's going to happen on the basis of certain filters and those kind of things, then probably there is not much point in storing that as a calculated column. And I think measures could be a better fit there. So just be conscious of those key distinctions when it comes to measures and calculated columns. Another key bit, which is super important when it comes to DAX, is that this is one of the mechanisms using which you can implement row-level security. So row-level security is available within Power Query, Power BI, which you can leverage. And using this, there are certain screens that you can work through, and I encourage you to explore that a bit more. But basically what you do is you can create a DAX function-based calculation, and then if the very specific user is part of a user role which allows the person or the user to explore that data, calculation will work for them. Otherwise, the data will not come through. So row-level security is quite critical, and direct query and DAX functions, they actually play quite critical role. In this particular case, you're seeing a screenshot where I've basically tried to look at what does this report looks like if I view it as a certain role, and then I'm calling out that I'm trying to be john@contoso.com. So I hope there is no specific Contoso out there, but if it's there, And if you are the legitimate John, your mention here is just coincidental. So again, there is a well-detailed documentation available on Microsoft Docs site, which you can step through and understand a bit more on what's happening, what should be done, and what you can do to leverage it even further. With that, let's get started with the third specific subset, which is creating measures using DAX. One of the most pivotal component or consideration rather when it comes to DAX is context. DAX is really good with understanding what's the context that you're running the query with, and then give you the very specific data set, very specific element of the data that should be returned back to you. So all the different visuals that you have on the screen, for example, and if you have DAX working behind the screens, you can work through all these different visuals and select multiple aspects of your solution, and those contexts will be passed on to all the different executions of DAX. So, for example, if you're looking at total sales by then total sales by year, and then total sales by product ID and those kind of things, you could be, for example, clicking on total sales by product ID, any one of those bars, and that very specific context will then pass on to other subsequent visuals, and all of a sudden the selected product ID related sales will then be shown for each year in the middle screenshot, and then total sales over the years for that particular product will also be shown in the leftmost visual. So that is how the context actually works, and something that DAX really are good at. Now, we have talked about calculations and DAX and everything. One of the things that we do need to think about is, at the very high level, DAX is actually nothing but expressions. For example, in this particular case, we are using a calculate function, and the way this will work is that it will have an expression in the middle, which is sum in this particular case, and then it will have a couple of filtering mechanisms. So in this case, we are using the filter which is for year 2015, and that's about it. So we have very particularly and almost hard-coded that this report has to look at the calculations on the basis of year 2015, and because that is actually our baseline for comparative analysis of any other year's report or any other year's sales, for example. One more thing which is not defined here and which is available in DAX, and I would like to remind you of that, and that is filter modifiers. You could also amend the same exact function call with things like keep filters and use relationships and those kind of things, and these are well documented out there as well, which will actually control and help you control what relationship you want to use when you deal with the data, and then the right numbers will be shown accordingly to you. So just a very quick recap on this. When you look at expressions, obviously it is looking at the expression itself, which is sum, average, and those kind of things. You might want to use some filters, which you have got on the example as well. And then lastly, you might have some filter modifiers, for example, use relationship. Not exactly a Power BI concept, but again, good to have this foundational understanding. There is also a concept of semi-additive measures. These are the measures, for example, inventory is a great example, right? What is your inventory today, and what was your inventory last week? They can't just be simply added up. That is representative of what is your inventory looking like as of this particular date, right? And they are quite useful in a lot of business scenarios, but wherever there is a time-based analysis going on, semi-additive measures are quite useful. So there are quite many functions which are available on the similar stride, and you could actually use a combination of these functions to really produce semi-iterative measures as well for your own business cases. Another key area which DAX actually focuses on quite heavily is time intelligence. And to be honest, I mean, if you think of any business application out there, any business area out there, there is a lot of focus these days on what is happening when and why kind of a thing. So time intelligence is one of the key pivotal concept and enabler that someone needs to be aware of. So please do spend some time on this. The list that's there in front of you right now, that's not to say these are the key ones and others are not. No, that's not the case. It is just to outline that there are quite many good time intelligence based functions available in DAX, and there are more out there. So please go and spend some more time on it. Try to understand what they are. And frankly speaking, a tip from my side personally would be that the names of these functions are quite self-explanatory. For example, dates year to date, you know what that is. Total year to date is something you are seeing. Dates between, you can imagine what that would be. And then parallel period is, for example, something like what is happening right now, what's been the parallel period in a specific previous year that you probably would mention. So all those kind of things are available, and these names are quite a good indicator of what is actually happening in that. But still, please go and spend some more time with it. Right. With that, let's go on to the last subtopic of this, and that is optimizing model performance. Now, when it comes to performance, it's a very specialized and very wide area. We can't go and put our finger on one technology or one solution or one tool and say, this is going to kill every single problem we have. That's never going to happen. So let's step back and think of the foundational concepts once again. I personally believe when you have solutions which are simpler, they generally perform better. And they are something that you can maintain well over a period of time as well. The same exact thing applies to solution in Power BI as well. If you think of the data that you need for reporting, you probably are better off thinking about, can I get just that data, or do I need to get everything? If you're getting everything, you know that's your first port of call where performance issues might creep in. When you have sourced the right amount of data, filtered in some cases, into your system, into Power BI system, from there on, you go and model the solution correctly. You model the solution in a way that relationships are established so that there is less and less chance of duplicate data. There is less and less chance of not useful data still sitting around. And also, it also gives an opportunity to go and basically trim the data volume by, for example, using the right data types or basically filtering the data where you need to. So obviously you can filter data even further when you have sourced the data. With all of that, and with that reduced data size, when you have created reports, the chances are going to be strong that your reports are going to perform well as well. With good relationships, reports generally perform better. With good relationships and understanding of the data, users understand the data better, so they will carry out the right aggregations as well, which are going to further enhance the usability of your reports. And once you go and publish all of that content and report size over to PowerBI.com, because of the synergized solution through and through, that's going to be reduced size and that's going to perform even better on PowerBI.com when committed capacity gets thrown at it. So when it comes to performance optimization, we have to think about not one tool at one point at the beginning or at the end. We have to think about the overall journey that the user and the data might have, and then work with that to basically optimize the performance in best possible way. And yet at the same time, also think about some of the moving parts, like what is my network optimization looking like? What is my network throughput? What kind of data sources do I go and connect with? Do I have some limitations on those? what are the boundaries within which I have to work, and basically work really with that. And when you do all of that, performance is really going to be very well. So again, let's go back and think about some of the solutions that's available. There is a great documentation available on relationship, and in particular man-to-many relationships, how they work. And this particular web page talks about not just for high-level many-to-many relationships, but actually goes and delves into things like, what does it mean for dimensions? What does it mean for facts? And it basically really gives you some clear guidelines and guidances on what you can do when you deal with something like that. Right. Now, one of the things that we also can leverage to optimize our performance is create aggregations and manage them, of course, over a period of time. You don't want every single user creating their own aggregations. Where aggregations can be really useful is you don't have to go and expose the most granular data, let's say on a daily frequency or a daily frequency or an hourly frequency or something like that, to your end users. If the financial team is looking at the numbers only on the basis of months, it could be month-on-month sales, month-on-month turnover, or those kind of things, then you know that they are interested in aggregation at that level. So there is not a lot of point in throwing the most granular data to them. And that's where aggregations can actually come in. So you could reduce your data footprint by using DAX aggregations and DAX calculations and those kind of things. So you could create those tables and only show those tables to the end customers and end users, and they will actually have a much better experience rather than having to know about how to do aggregations by themselves. As you can imagine, this ties back a lot to you having some fair good understanding of the business requirements, and then you work with that. But if you have spent some time, and generally, enterprise solutions are mature enough to have this kind of consideration, if you have done that, there is a good chance that you will need aggregations. And when you do that, as you can imagine, this particular case, the example which shows you have the granular table, which has about 14 columns and obviously almost 1,000 records or more probably, versus the outcome table, which has only 4 columns with 30 rows. You can imagine what will work better. Again, there is a good outline of what is there in creating aggregations, what are the tips and tricks, and some bits of those information, which will be covered as part of this documentation. Right, so let's look at one demo. So we did cover 2 ODs so far. One was about sourcing the data, and this one was about modeling the data. So let's go and look at it together. So we have a Power BI window open right now. Now, a few things that you might want to think about is there are certain options that you should explore a bit more on, which sets the way the data itself is sourced. There are quite many data sources which are available. In this particular case, we are using SQL Server-based data source, which is a local host actually. Once you have got the data sourced, you can actually explore your data on the main screen itself. So you don't have to really load the data. You got the data, you can look at it, what kind of columns, what kind of data types is there, and then you can work with it if you like. So now I go and select very specific entities that I want. So I don't want this, I don't want that. Let's include this, and let's have some more tables added to the data model. Now I will go, instead of load, I will go and transform the data to show you Power Query data. Just to show you, all of the data sourcing is happening through Power Query. And if you see the editor, you can see the code working behind the screen. So you can explore the data a bit more if you like. Let's do some very quick cleansing. And if you think what I'm going to do is all these are date time, I just want to convert them into date. And one of the things that you probably should notice is that in applied steps, it's not going to add more and more steps. These are exactly the same executions, and that's why it retains the change type as only one step, although I'm changing 3 different columns at the same time. Now what I want to do, I want to reduce the data volume, and I will filter my data. This is a fact table, so this is going to be my bulk of data volume anyways. So I'm going to filter it to data which is after 2013. So that's that. Again, the same thing, I can explore my data. Now let's look at profile. So if you think about it from sales territory perspective, it can show that there are 7 unique and 11 distinct values, which is probably okay for me if I know the data. I can look at the column profile as well, which is again showing me some more details. And then overall column quality, whether 100% are valid or if there are errors and those kind of things which I need to deal with. Now with that, let's do some quick text transformation. So there is first, middle, and last name. Rather than having them separate, I want to merge them into one. And I'm all doing that using GUI. So I'm separating all of those values with a space, and I'm just calling it employee full name. So the previous columns are gone. If I want, I can explore them still by going back in the journey. I want to choose column. Now, if you think I can actually insert steps in between, and that is something that I tried earlier, which I don't want. So I'm coming back to the last one. And then I'm trying to choose columns, which I really want to use. Again, one of my mechanism of reducing data footprint. So I just want these, this, and a few more, and I think that should be good. Yeah, let's go. So whatever cleaning, transformation, and everything that I needed to do, I have done that. Now I'm loading the data. Now, there are multiple views within Power BI that you should be aware of, and something that I encourage you to spend some more time on. So let's go and look at the model view. So now, again, reminding you that I've not changed anything in the model. So this is the model which has been sourced exactly as is from the data source itself, and there are different relationships, and this particular one is a single direction. I could use bidirectional and those kind of things as well if I want to. So I'm not going to change much on the model itself. There are roles that you can define at this level, and a view as is another screen, if you remember, that we touched on. So let's just quickly touch on that as well. So I can define whatever user I want, and I can put that XYZ at contoso.com or whatever, and go from there. So let's do one thing. Rather than just accepting exactly as is, let's just, for the fun of it, let's create an hierarchy at the modeling level. So which can then be used by the users, and it will be visible to them. So let's try to create a hierarchy for geography. And in this particular case, we will just play around with, just a bit of a country, region, and those kind of details. Now, this is obviously not the absolute reference. I'm just playing around with just throwing anything that I want. So I've taken country already. I am bringing in territory now. And just for the fun of it, let's probably bring in region as well. And if you notice, this is actually coming in the model as well. So that's about it. So this is where I'll leave, and let's go forward. So before we wrap up this particular OD as well, let's again do some quick practice questions. And again, we will do the same thing. We will call out the questions and the options we have. I'll wait for some time. You choose the answer in your mind, and then I'll reveal the answers as well. Let's go. So the first question is, one table in a relationship can be used to filter the other. This is example of, options are bidirectional cross-filtering, single cross-filter direction, cardinality, or none of the above. The answer is bidirectional cross-filtering. Just because one table is able to filter other, it also could lead to that the other table can also filter this. The next one is the fundamental difference between a calculated column and a measure is that a calculated column creates a value for each row in a table. Is this true or false? The correct answer is true. So let's go and review what we talked about as part of OD2. So we started with relationships and cardinality and cross-filter directions, resolving modeling challenges, how we go and do that. We also explored data analysis expressions, or DAX for short. Within that, we also introduced calculated columns and quick measures. We also explored a bit more on row-level security and how DAX can help in that. And we talked about calculate functions. There are a lot many other functions available in DAX, but I think calculate is quite fundamental, and hence we went about that. Other than that, there are semi-additive measures and time intelligence capabilities in DAX that we should be aware of. And then we also looked at performance optimizations and some thought process around that, and also focused on many-to-many relationships and creating and managing aggregations. And that concludes the objective domain 2.